Okay, in example 1, we have 4y plus 5 squared, which is the same as 4y plus 5 times 4y plus 5. Now, you could easily do this with the FOIL method, but that would take a long time. Instead, you could use a simple and faster method, which is called special products. These are special products because they are multiplied by each other, which is also a squared. Now, for example 1 here, we're going to use this expression, a squared plus 2ab plus b squared. Now, your first thing to do is you need to determine which one is a and which one is b. The first term is a, and the second term is b here. So now that you know which one is a and b, you can plug them into this expression here, which is going to be a squared, so 4y squared, plus 2ab plus 2 times 4y times 5 plus b squared, which is going to be 5, which is b, 5 squared. Good. Now you can solve, so 4y squared is going to be 16, because 4 times 4 is 16, and bring down the y squared because it's distributed to each term. Next, you're going to do 2 times 4y, so plus 8y times 5, plus 5 squared is going to be 25, which is the same as 5 times 5. Next, you're going to multiply 8y and 5, but before you do that, bring down the rest of your terms. Now 8y times 5 is going to give you 40y. So your solved answer is 16y squared plus 40y plus 25. Okay, so in example 2, we have 5m cubed minus 2n squared. So instead, you have a negative instead of an addition. So you're going to use this equation, or this expression, excuse me, here instead of using the previous one I showed you. So just like the last one, this is the same thing as 5m cubed minus 2n times itself 5m cubed minus 2n. Again, it's the same thing, so don't panic. So you have to determine which one is the a and which one is the b. So this is the a because it's the first term. This is the b because it's the second term. And just plug it in like normal again. 5m cubed squared. But instead of adding an addition, you're going to add a negative. So minus 2 times 5m cubed a times 2n b, which is the b term. Next, you're going to have the next term, which is going to be plus 2n squared, following the expression here, which is plus. So it goes plus minus plus when you have a negative in the binomial. So next you're going to do the method, or solve, which is going to be distribute this one to each term. So 5 squared is 25. And then you have an m cubed, which is going to be 3 times 2, because whenever you have a power to a power, you're going to multiply them. So 3 times 2 is going to be m to the 6th. And now you have negative 2 times 5m cubed, which is going to be negative 10m cubed, times 2n, plus 2n squared, which is going to distribute it to each term. So 4n squared. Next, you're going to multiply the middle terms here. So 25m to the 6th, and negative 10m cubed times 2n is going to be negative 20m cubed, and then n, just n by itself, plus 4n squared. And that's your final answer. Okay, so in example 3, they give us a Punnett square and want us to find the possible gene combinations for 2 hamsters. You're going to get a binomial because you're finding the gene combinations for two hamsters. So let's start out with explaining what the Punnett square is. A Punnett square is used for finding genetics and how the genes are used, and which one is recessive, which is not common, and which one is dominant, which is very common. So GG, pure golden, is going to be a recessive gene, which is here. G, capital G, lowercase g, is here and here, which means it's common. And lowercase g is pure cinnamon, which is not common because it's only 1 out of the 4, along with GG. Now now we're going to need to write 2 binomials, which I already wrote down here, which is going to be 0.5 capital G plus 0.5 lowercase g. You get the 0.5 because each of the capital and lowercase g are in 50% of the are in 50% here and here. And here. So now writing a binomial, it's just going to be 0.5 capital G plus 0.5 G squared. And now you're just going to solve this like a normal special products. 0.5 G squared plus 2 times 0.5 capital G plus 0.5 lowercase g plus 0.5 g squared. Plus 0.5 g squared. It's kind of messy right now. So you're going to solve this, and 0.5 squared is going to give you 0.25 capital G, because that's your A term. This is your B term. G squared plus 2 times 0.5 is going to give you 0.25 capital G lowercase g plus 0.25 g squared, because you have to square the last term, plus bring down the 2, so you have to multiply this one by this one here, so bring down the rest, 0.25 capital G squared plus 0.5 capital G lowercase g plus 0.25 g lowercase g squared. Thus, this means that the 25% of the offspring will be capital G, or pure golden. 50% of the genes could be hybrid golden or hybrid cinnamon, because you have 0.50 here, which is half, and 0.25, or another 25%, could be lowercase g, or pure cinnamon.